Our next topic is 5.4, indefinite integrals. What we were just talking about in 5.3 were definite integrals. So now we're going to learn what indefinite is. So, indefinite integral is the most general antiderivative of f. So, the punchline here is that indefinite integral is just the most general antiderivative, big F of x. And so, we know pretty much how to do this section already. We just have a few things to put together, and we have some new notation. Also, from the Fundamental Theorem of Calculus Part 1, in essence what that's saying is the derivative undoes the integral. So here we're saying that the integral undoes the derivative, and so we have some notation associated with this. Also tells us how to evaluate the indefinite integral. So note that what I have in red here, the way that you can detect an indefinite integral versus a definite integral is that values of a and b are missing. They're just not there. So that means that it's an indefinite integral, and it's just straight up the most general antiderivative of the little f of x that's inside of that integral notation. So let's do a quick example just to make sure we understand. We have the integral of 6x squared. No little a's and b's here, values there, which means this is an indefinite integral, and this is just going to be the most general antiderivative of 6x squared. Well, that's just 6 over 3x cubed plus c. Simplify, and we're done. So it's 2x cubed plus c. And we can call it a day. This is actually way easier. Well, maybe not way easier, but this is easier than a definite integral in the sense that you had to do this work anyway, and then after this, for the definite integral, you had to plug in the b value for x, the a value for x, and subtract them to find the result. So here we're just done, which is nice. So now that we've learned that, we're going to have a little bit of a notation, but pretty much we're going to have all these rules now, which are pretty much what you had in section 4.9. So those are indicated here. The blue ones are the ones that you need to memorize. There's a few down here at the end that you do not need to memorize, but if I gave you that rule, you should be able to do it. And those are with the hyperbolic functions. So backtracking here, it says that indefinite integrals are a family of functions. So in terms of an integral, why this is different, indefinite integral is different than a definite integral, this is like a family of functions with that plus c part, and it's not over any particular interval, it's just left kind of generic, which means that it's a function and that it has its own domain. The plus c makes it a family of functions because basically we could have the same shape, but it can be shifted up or down with the plus c. Down would be a negative value of c. So that's why it's a family of functions. And so just iterating what I said already above, the definite integrals 5.2 and 5.3 use antiderivatives but result in an answer that is a value which represents the net area. And so in the definite integrals, you know, they're very similar, but they're not necessarily indicating that. You could go ahead and look at it on an interval and turn it into a definite integral, but the indefinite integrals are a family of functions, they have a domain, and they're like when we had the derivatives of function, this is sort of like the integral as a function. So that's it for this recording. In the next one I'll do 2 examples and then we're done with this section, being that pretty much we've already done a lot of these problems in 4.9.